This is a ball. That was it bouncing. What you guys need to know is the VT graph that describes that motion. So let's start from the top, quite literally. So we're going to begin by looking at this wee simulation on the board. So if I drop this ball, then firstly it is under the force of its own weight, okay, force due to gravity. So naturally that ball is going to fall and it's going to speed up like that. However, it doesn't stop there. Eventually that ball is going to hit the ground, and rather unsurprisingly, when that ball hits the ground, it's going to come abruptly to a stop. Well, it would do if you were holding on to something like cabbage. We've all been there, walking down Princeton Street and we've dropped a cabbage. It's a disaster. However, the story thankfully doesn't end there, because this is no cabbage. This is a bouncing ball. Okay. So I wonder what would happen next after it's contacted the ground. Well, some people would say that, oh well, speeds up again, so it's going to do that. But there's a problem with that, because that is kind of the same as that line, and that line showed the ball falling down. So if this was true, then the ball would fall down, hit the ground and come to a stop, and then somehow miraculously smash through the table and continue falling down. Okay, that can't be right. So something must change. And in fact what the ball is doing is it's changing its direction from falling down to rebounding up. And on a VT graph, the way that we represent a change in direction is that you slice right through the zero axis. Now this represents that the ball is moving in the opposite direction. In fact, it's starting to move upwards. So if I now play this again, and feel free to fast forward and slide this video back and forth to see how this all works. So if I play this video again, the ball at the top falls down and smashes into the ground. And there you go, a very steep line. Why is it so steep? Well, it's only in contact with the ground for a fraction of a second. And in that time, it's got to go from a big downward velocity to a big upward velocity. And so that's going to require a very rapid change in velocity. Again, the story doesn't finish there, because at some point this ball leaves contact with the ground. And at that point, it is once again under the mercy of gravity, of its own weight. And that weight is, in this occasion, going to gradually slow it down until it once again hits the zero axis. And what's happened there? Well, the ball is now at the same point it was here. In fact, the ball is now back up at its maximum height again. I'll play the whole thing through for you so you can see it nice and clearly. Maybe get rid of my little blue line. So falling down, in contact with the ground, and immediately rising up to a maximum. Beyond that point, and you probably saw it there, the whole cycle then repeats itself again. Once it gets to a maximum height, starts falling down, and then rebounds off the ground. if you were to label the parts of this, it would be falling here, rebounding all the way along here, and then from the bottom section to the 0, rising. Don't be surprised if in some textbooks these graphs are inverted, so that it starts going down and then juts up the way. Okay, that's just a difference in what we're calling positive and negative. But the theory, the basic concept is still exactly the same as that. Another final point to mention is any time a line is moving away from the 0 axis, the ball is speeding up. And any time a line is moving towards the 0 axis, from either side, the ball is slowing down. Okay, I've got to bounce, but I hope you find learning this a ball.